Okay, so I'm recording this meeting and I am sharing with you my desktop. Okay, so here I want to remind you that all of you should have received an email from NCSA Delta for setting your username and password. I mean, your username has been sent to you, and you just needed to reset your password. We are using that credential in order to log into Delta. Okay, so with that, I opened the terminal. I showed you earlier how you can, on Monday, we learned how we can open a bash shell. So whether you are a Mac user, a Linux user, or a Windows user, now you all know how to open your bash shell, right? So we have that. This is my terminal. And what I need to do, the main commands that we are using today have been shared with you on Canvas. So I'm sharing with you the Quartz Canvas shell, and you just simply go to modules. And then here we have lecture 4 materials. So the first part is on NCSA Delta and how we can log into that, right? So I just simply copy this line and then paste it to my terminal. I remind you that some users are not allowed to copy and paste. I think on Windows, maybe you cannot copy and paste. I'm not sure about Linux. So if it's not the case, you just need to simply type this in. So you type it, and then here you need to change this part, right? So I'm showing username in the two brackets, but you need to update it to your username, the one that you received from NCSA Delta. So this is my username. And as I explained to you earlier, all the commands that we have start with the prompt, but we don't really copy and paste prompt, right? Because, in my terminal, I already have that. So the command starts from here. And this is basically the argument that we're passing to SSH. We are securely connecting to this server, right? So I let you copy and paste the command or just simply type it. Replace username with your own username. And once you're done, you just simply press enter. What happened? I just logged into.
I already set my account, but do I have to actually reset the password or do I already set the password? I'm confused.
You can use the current password that you have, but if it didn't work, then you can try the reset password button. Okay, let me see what happened. I just logged into Delta.
Sure.
Okay, let me see.
You're just missing
Oh,
a period.
NPSA. Where is it? Okay. Oh, isn't it? What? Okay. Literally. Okay, I don't. Oh, there is a missing dot there or something? No. Oh, okay. It happens. I don't know. Um, Let me copy and paste it again. Okay, so it's login.delta.ncsa.illinois.edu, and this is I don't know what's happening. Okay. My username. Okay, so you should receive something like this, and then you need to type in your password, right? As you're typing, you don't get to see it because it's secured, right? So I just typed in my password, then I pressed enter, and then you get to receive something like this. This is the do push setting that you should have set up already on your Access account. So I have my cell phone number in here, and when I type 1 and press enter, it sends me a do push. So I get to approve it on my cell phone. Once I approve it, I get to see this Delta logo, right? And then if you notice, I'm not on my personal computer anymore. I'm on Negin F1368 at DT-login04. So I'm on one of the login nodes of Delta right now. Okay, I'm gonna pause here because I know many of you might not be there yet. So take a few moments. I'm also going to check the chat box. Okay, so I see some of you have problems with your do push. Um, I believe if you have followed the instructions on access, you should have set it up easily. But if it's not the case, then I think we should work on it separately. I don't think this is a problem we can fix very quickly now, okay? So I see one comment from Jeremy who couldn't approve the do push. Is there anyone else who is facing the similar problem or not? Okay. Okay. So again, make sure that you have followed the steps that I just explained, right? So you SSH your account, you type in your password, and then you should receive something like this. If it gives you an error, it means that you have not set up the do push on your cell phone. What I did was to, when I was creating my Access account, there was a barcode. I scanned it on my cell phone with my do app, and then I added Access to the list of institutions that I have on my app. So for example, all of you should have, Casa Delay on your do app, right? If you follow the steps for Access and also NCSA, you get to see them added to your do app. If it's not the case, it means that you didn't set it up correctly, so you should spend more time on that. I understand that some of you cannot log in. That's correct, Anthony. So there is one barcode for NCSA and there is one barcode for Access. So you need to set do app for both of them. Again, on my app, I see both. I see Access and I see NCSA. So when I just want to simply log into my Access account through the website, I approve that do. Whenever I want to log into Delta, I get to approve the do for my NCSA account. Okay. Yeah, I know it's a little confusing. As I explained earlier, there is this Access program, which is more like an umbrella program. There are different supercomputers that are in that program, and we're working on Delta. So you need to have accounts and do pushes and everything set up in both Access and NCSA. Again, Reda, make sure that you are enrolled in do for NCSA and Access, both of them. Okay, so I'm gonna wait here for 2 more minutes. We wanna move on to the next steps. Again, I'm recording this meeting, so if you couldn't follow me, it's okay. You can always watch the video later, okay? Let's spend just 2 more minutes here for those who are setting their do pushes. If you could do this successfully, if you get to see the Delta login, please type, don't know, success or done or something like that. So I can get to see, okay, there are some people who are already there. Sounds good. Sounds good. Okay, so if you are curious about what this login node is and how many login nodes do we have on Delta, you can always read more about it on their website. Just simply you can search NCSA Delta, right? And then if you want to know more about their hardware, I mean, how many login nodes they have, how many compute nodes they have some information here. I also believe that there was another website that was very helpful. This is for their AI. Okay, there we go. It's here. I'm going to share that information with you in the chat box. So you can see that, the information that I shared with you on Canvas, I borrowed from here. There are different ways for logging into their login nodes, right? And then if you're wondering how many nodes they have for computing or logging in, then you can, find more information in here. Okay, so with that, let's get back to what we have here. Some of you might be with me on login node number 4. Some of you might be on login number 1, 2, 3, or if you have more, you might be in other nodes, okay? That's not a big deal. According to their availability, they assign you to different login nodes. So from here, we are going to practice some of the commands that we learned on Monday. Recall that we are now using terminal to access to that remote supercomputer, and the only way we can communicate with that is through command line, right? So what we learned on Monday is applicable here. We're going to practice some of them. So first of all, where am I? Do you remember what was the command for finding your working directory? The path pwd. Okay, so let's try that. So I'm in users, and then this is my username, right? So this is where I am. And then how would I find all the files and directories that I have in my current working directory? What was the command for that? ls, okay. So if I ls, because I've been using this for a while, I get to see some directories and files. Most likely you don't see anything on your end because this is your first time logging into Delta, okay? So with that, the next step is to create a new directory, and then we are going to practice some Slurm commands in that directory. So do you remember how we create a new directory? Make dir sounds great. Okay, so I already have created a new one. I called it CS4635_S25. So if you want to do this for the first time, you do mkdir, and then this is the name that I would suggest that you choose for the course. Apparently, you can choose anything else. You create your directory, and from here, you want to go to that directory. So how would you go to that directory? What was the command for that?
CV.
Right. So we change directory. We go to this one, right? And if I ls, again, I have put some files in here, but most likely you don't get to see anything. So this is your first time working with it. So what we want to practice today is to run Slurm jobs in 2 different ways, interactive mode and also a batch mode. And I'm going to explain what I mean by those things. So before that, I'm going to give you a brief introduction about why we need to work with a workload manager, what exactly that is. And then we're going to learn some commands to work with the workload manager, right? So when you have your own personal computer, your desktop, your laptop, It's just you as a user, you're working with the computer. But when you have a shared resource, as you can imagine, it's a different story now. Now there should be a higher level workload manager to decide what resources should be assigned to each users. When we have a server, a big workstation with so many demands, there are usually different queues, right? And then the users have their allocations or their accounts on that system. They are in different queues, and based off of that, the workload manager gives them different priorities for running their jobs on the compute nodes. This is different from the operating system. So the operating system is like a lower level system for managing the files, data, and stuff like that. So here we're working with the Linux system. That's the operating system that is installed on that computer. But then on top of that, we need to have a workload manager to deal with the demands and also the resources that we have available on the computer. Okay. So that's why we need to learn a few more commands in order to run our jobs on that supercomputer. The very famous workload manager that is, the most popular one on many of the supercomputers and workstations is called Slurm. There is another one, it's a bit older, it's called PBS. So if you want to work with that, you need to learn those commands. But as I said, Slurm is the most popular one. It's installed on Delta, so that's why we're going to use it. Okay. So now we are going to run a very simple Hello World Python code, right? So first of all, we need to create that file. Do you remember what was the command for creating files, or if you want to use a text editor, how would you work with that in order to open a new text file? Yes, Anthony. So touch is for creating a new file, but since we want to type a few things in there, maybe it's better to use a text editor, right? So we get to also work with in the file. And so we introduced Nano in our previous meeting, and we have those all the commands and hints in Nano whenever we open it. As I mentioned, I'm more like a Vim person, so I'm going to use Vim now. I think it's also a good practice for you to see how it works, but whatever you choose, it doesn't really matter. You're just simply opening a file, writing 2 lines of code, and then closing it. So whatever works for you, go with that.
Can you slow down, because Vim is by pressing the keyboard. We don't know what key to press.
Yes. So I'm going to call Vim. I have already created this file, right? But it doesn't matter. If it's your first time, you just simply type in here hello world.py, right? So we have Vim space hello world.py, and then you press enter, right? Okay, if you're using Vim, then you are not in the inserting mode first. So you need to press I in order to be able to type something, right? So now you see that I'm typing something. Again, this file currently exists there. So I'm not typing it again, but
So I just get a lot of lines on it. I just type Vim hello world and I get a lot of lines. So what do I do? You said I need to type I or what?
just wait a minute, we'll get there, okay? So we pressed I. When you press I, you're in the insert mode. If you continue pressing I, it means that you're just typing I, right? We don't need that. I'll just delete it. Then we have this first line. This is just a comment for you, right? So I copy and paste in the chat box. You can place it there, or you can just simply skip it. It doesn't matter. And then you press enter, and then next line, you just simply print hello world. Again, I copy and paste it here for you in the chat box. Okay, that's it. I'm done. So I press escape on my computer. When you press escape, it means you are not in the insert mode anymore. Then you press shift colon, right? Shift colon. And then you type W for writing and Q for quitting. And then you press enter.
So can you show it again?
Yes, so I vim hello world.py. I'm in here. So if you typed everything correctly and if you stored it correctly, you get to see the commands here, right? Otherwise, if you're still there, you need to press I in order to switch to the insert mode. I copy and pasted the 2 lines of code that I have in here. So once you are in the insert mode, you just simply copy and paste them. Then you want to quit from the insert mode, right? So you press escape. Then you press shift colon W Q. I'm writing that in here. So in the chat box, first of all, you need to escape, then shift W Q, right? And then you press enter. Okay. So if you just simply want to check the content of your file, do you remember how we print out the content of the file? What was the command for that? If I don't want to open it, I just want to print the file. Do you remember what was the command for it, the Linux command? Echo, I mean, it's cat, right? Echo is mainly for the variables. Yes, so if I cat it, you get to see what's in the file. Again, you can use Vim for opening it. Everything looks good. I simply quit, and that's it. Okay, so we created our first hello world.py file on our account on Delta. Okay, so from here, we want to run this command, right? So one thing we can do, I mean, you may say, why are we bothering? I mean, why just we don't simply, call Python inline and then run our code. This is something that is very discouraged, and it's a very bad practice to run any simulation, any code, any job directly on the login node. Okay, so whenever you SSH to a remote server, you are transferred to the login node, and login node is just for logging in, right? It's not for really computing anything. You need to move to the compute nodes in order to run your job. So here you have 2 options. You can either start an interactive session on a compute node in order to run your code, or you can stay here in the login node and then submit a batch job, which takes care of running your simulation. Okay, we are going to look at both together and see how they are different. Okay, so I'm going to pause a little bit here to make sure that most of you are following me. If you were able to create the Hello World file in Python using Vim, please, share that in the chat box so I can understand that the file has been created and you're following me. Okay, I see a lot of yeses in the chat box. That's a great confirmation. Okay, sounds good. So from here, let's start our first interactive job on Delta. So recall that I told you that whenever you want to submit a job, you need to have a valid allocation on that supercomputer in order to do that, right? So once you have your username and password set up, it means that you're just simply allowed to connect to that remote server. But in order to be able to run any jobs, you need to have a valid allocation, right? And that's what I have created for you. We have it
Hope you're
at
doing well. Bye-bye.
Sorry. Okay. Make sure that you're muted when I'm presenting because, you know.
I'm sorry. I
Oh.
just forgot.
Okay. Okay. So from here, what we need to do, I mean, this is a command that you can use in order to check your accounts on Delta. It's for some reasons a little slow on my end, but I just simply typed accounts and then I pressed enter. So you can see, all of you should see these two accounts here. One is our CPU account. You see the number of CPU hours that we have on Delta, right? How much balance that we have and how much we deposited. And then this is our GPU hours. Okay, and this is our course, CS4635. Okay. So again, all of you should see these two on your end. This proves that you have been added to the account on Delta successfully. This is what I did earlier on my dashboard, so you don't have really any control over that. Okay, so from here, I am going to switch back to Canvas. We do have a command for running an interactive job in Slurm. Okay, so we are. I'm just simply copying it. Again, we are skipping the prompt, and I'm pasting it in here. And before running it, let's see what exactly it's indicating. So it's a Slurm command. All the Slurm commands start with S, right? So it's S run, or in other words, it's running an interactive job. Then -A, we call that all the commands, they have some options or flags, right? So we have different options in here. The first one, some are required and some are optional. So accounts, for example, is required. You need to indicate the account that you're using for submitting the job. I just simply used our CPU account in here. And then I indicated the amount of time that I need for running this interactive job. So it's just simply 30 minutes. You see we have 3 places here for hours, minutes, and seconds. We are opening an interactive session for 30 minutes. Then this is the partition. We are running a CPU interactive session. We only employ one node. Then you indicate the number of tasks per node, then CPUs per node. So when later we are going to work on parallel computation and we require more than one task per node or maybe multiple nodes, then we are going to change these things. But for now, we are just simply setting both to 1, and then we say 4 CPUs per task. It's more than enough for our simple hello world code, but we go with that. This is the memory that I indicated here, and we're using a bash shell. Okay, so if you just simply press enter, your interactive job request gets queued, and then it allocates resources. This is your job ID. So later, if for some reasons you wanted to check the status of that job, you always need to have your job ID. I'm waiting for it to start my interactive job session. If you're all running the same command, you can imagine that it would take us a little longer to get there. That
Mine
problem.
says error. That's wrong communication socket apparently. There's something wrong with the boot of the nodes.
You can copy and paste your error message in the chat box, and then I can look at it, or TA can also look at it. So we should be able to fix it. But I just simply copied and pasted what I shared with you on Canvas. It took me a few seconds, but then after that, you see I'm now on a compute node, right? So previously I was on a login node. After opening the interactive session, now I'm a compute node. Again, you are not necessarily on the same compute node that I am. You can just simply type the compute node number that you see on your end. I'm curious to see how many compute nodes we have out there. So if you were able to run your interactive session and you are on a compute node, just simply copy and paste this to the chat box and then share it with the class. Oops. Okay, I see 43, 103, 45, 37, 40. Okay, sounds good. Perfect. Okay, so with that, again, I'm gonna wait here a few more seconds because it took me a minute or two to see the interactive job session working. So maybe it's taking some of you some time. So once you are there, then you are more than welcome to run any jobs on that compute node, okay? So what I can do is to just simply type Python 3, and then I have a Python file in here, right? It was hello world.py. So I run this command and it prints out for me hello world, right? You should be able to do the same thing. Python has been loaded to your accounts by default, so you don't need to load anything new. You just simply call it, and then it runs the code for you. So if you were able to do that, then give me a confirmation in the chat box. Okay, so it's running, sounds good. I wanted to give you some more information about the modules that are already, by default is added to your account. So if you just simply type module space list, enter, it lists for you all the currently loaded modules onto your account. So you see that you have GCC, this is its version, this is your compiler, you have OpenMPI for parallel computation, CUDA for GPUs, and then you have your login environment, you have your Slurm environment, and some default setting. So these are all the modules that, by default are loaded to your accounts. So again, recall that we are connected to that supercomputer and there are multiple accounts in there. So some of these compilers and maybe software are installed centrally, so all the users have access to them. And then some of them are not loaded by default. They are available there, but they are not loaded by default. So whenever you want to work with them, you need to load them manually. If you're wondering what modules are available on Delta, you can just simply type in a module spider. It opens something like this for you. It's the complete list of the modules and extensions currently available on Delta with all the versions and everything, right? So if you press enter, it goes down. So for example, you can see Anaconda is here, AWS, and so on. If there is a specific module that you're looking for, so I'm typing Q to quit this, and I'm clearing my screen. So if there is a special module that you're interested in, for example,
How do you leave the command?
You type Q. Then you quit the list, and then I cleared my screen with Control L, and now I'm typing module, spider, for example, anaconda. Okay, so if you want to know what versions you have available in there for anaconda specifically, you type in the name of that module, and then you get to see that there are different versions there. We have the CPU version, the GPU version. You press enter, it goes down, and whenever you want to quit, you just simply type Q and you're out. Okay. Again, I clear my screen. Okay, so let me ls again. You should only be able to see this hello world.py file that you generated, and we were able to compile it. We don't want to do anything else in this interactive session, so I'm just simply typing exit to exit this interactive session. Once you do that, you are back to your login node. If you type exit again, I don't want you to do that now. I'm just giving you this information. If you do this once more, then you're out of Delta and you're back to your local computer. We are going to do that when we are done with this meeting and we want to end that connection to Delta. But for now, we want to stay on the login node. Okay, so that was the first way for submitting your jobs. Interactive job sessions, but they are very helpful whenever you are just debugging, testing, developing. You have very small, very short jobs. You just want to open them, make some changes, and compile them. Then the name is pretty straightforward. They're interactive and they're helpful. But as you can imagine, when your simulations get longer and you want to run them for maybe a few hours or even days or weeks, then it doesn't make sense to start an interactive session because if there is a problem with your network, if you close your terminal, if something like that happens and you lose the connection to the server, then your job ends. And then that's not what you want when you're running a very long job. So another way of running jobs, again, specifically for long jobs, is by submitting batch jobs. So in that case, you submit your job, then you can, just simply disconnect from Delta, go have your lunch, have fun, come back, and then check the status of your job. Okay. So that's the benefit of running is a batch job. It's not interactive as what we saw earlier. So whenever you want to check the status, you need to go check the output file and maybe you put some flags in the code to see what's really happening in there. So that's maybe the downside, but the positive is that regardless of your network connection, the job is running on the CPU or GPU nodes until your required time on it is over. Okay, so we are going to look at a batch job command together, and for that we need to open a new file. Recall that with Linux you don't really have to indicate the extension. This is just for convenient. So I'm opening a new file. I'm using Vim. You can use Nano, Emacs, or anything else, right? So I have Vim. I call it hello world.slurm because I want to have my Slurm file, and then I'm going to submit that as a batch job. So I Vim hello world.slurm. I already have the file in here and I have shared the content with you on Canvas. So if you just simply switch over to your Canvas, you see that I have shared with you all the content. So you just simply copy and paste it in your file. Again, when you use Vim, you are not in the insert mode first. So you need to press I first in order to switch to the insert mode. Then you will be able to paste that content into your file. And I don't know why I have two of these. I don't need this one. Okay, we can look at the structure of this file together. We call our bash shell, so we are using a bash shell, not a different shell. And then all of these settings here, all of these options, I mean, not all of them, most of them are those that we also used in our interactive session, right? So recall that in our interactive session, we also indicated our account, we indicated the number of nodes, memory, the time that we need for the job, and so on. So we have a pretty much similar setting when we submit a batch job. Some of these options are not required. I just added them here for your information. For example, the job name is not required. It's just for the convenience, if you're running multiple jobs, you can name them so you can differentiate between them easily and so on. But some of them, including account, is required. So very similar to what we had in our interactive job, we need to have some required options set up for running our batch job, right? And every line starts with the number sign and then S batch. So this is how you indicate that you are, sending values to these variables. And once you're done with the header of your file, then you just simply copy and paste the code that you want to run. Many times, here you are basically calling the compiler or the interpreter. Sorry about that. So you're calling the compiler or the interpreter, and then you call your file. So you don't really want to code anything inside your batch job. It's just for letting the workload manager know how you're setting your job, and then you call the compiler and then you code. Okay, so try to make this file very simple, very clear, and then whatever code you want to have, you just change it in your Python file or whatever you're working with. Okay, so with that, when I'm done with typing everything, again, I press escape, then I press shift column WQ, enter, and I'm out. Okay, if you want to look at the content of your file, you just simply cat it. You should be able to see something similar to this, right? And now from here, we want to submit our batch job. So the command for running, for submitting a batch job is S. All the Slurm commands, they start with S, right? It's S batch. And then you indicate the name of your batch job, which in this case is helloworld.slurm. Okay. I'll copy and paste this in the chat box for your convenience. Right? So you just simply press what happened. Oh, I think I made a mistake. Let me see. Oh, I deleted that line, sorry. So let me copy and paste it from here. The first line always starts with this. And then S batch, hello world.slurm. Okay, so once you submit your batch job, you receive this ID. Then you can check the status of your job by typing SQ-U and then your username. Okay. So you see that the status of my job, first it was pending, Now it's running for 6 seconds now. There is only one node required for this job. And then you see my job ID. This is the one that I received here. It's running on the CPU partition. I named it as my job test. And if I check the queue again, I see that it's empty now because my job finished, right? So if I ls-lt to list the files in this directory based on the modification date, I see that I have this output file. This is generated by the workload manager. So this file, it has a standard structure. It always starts with slurm dash, and then you have your job ID dot out. So if you're running the same Slurm file over and over again, every time you make some minor changes, it changes the ID for you, and when it outputs for you, what the code returns, it gives you this hint in here, so I can make sure that this is the output of my recent job. So with that, let's open this output file and see what is in there. If everything goes well, you get to see this hello world printed in the output of your Slurm job. Okay. So I'm gonna pause a little bit in here. You can also cat it because it's just a one-line file. I'm gonna pause here to see how many of you were able to run this SBAT job successfully. So please give me a confirmation if it worked fine on your end.
When I run the XQ, it doesn't give me no job ID. It just gives me recent features.
XQ?
Reason.
Oh,
It doesn't give me anything.
okay. So did you run sbatch.helloworld.slurm?
Yes, I did.
Okay.
Batch hello world.slurm. Yeah.
Okay. Yeah, let me give you an explanation here. So the reason is that in our simple Hello World this is, as you can imagine, it wouldn't take more than a few fraction of a second, right?
Oh, okay.
For the system. I intentionally wanted it to run for 10 seconds to be able to show you how the queue works, right? But it's just there for 10 seconds. And when your job is finished, there is nothing in your queue. So if you're curious, if you want to check it again, you can run sbatch again. So let's do this again together. So if I do sbatch hello world.slurm, this time I have this job ID, right? So if I do sq dash u my username,
Oh, okay. Now,
just a few seconds. I mean, you can change that time if you want, the job to stay there for a few more seconds. Mine is still pending.
oh, okay. Yeah, I got something now. Yeah.
Got it? Okay.
Thank you.
Yeah, it's very helpful when you're running a very long job and you want to see how many seconds or hours or days it's been running. So it's usually helpful for that. For a small job like this, it's just, a practice.
Okay. Thank you.
Sure. And I believe if you don't indicate your username, you get to see all the users who are running their jobs on Delta. So if you want to just do a sneak peek and see who's there, I would imagine that some of these people are you, the students who are in the class, right? And some of them might be some just random users. And it could be a very long list. So if you want to terminate it, just press Control C, and it stops printing the status of the entire queue, right? So again, as you can imagine, there's so many people in there. Some of them are running jobs with OpenMPI, so it's running on multiple CPUs. It's a parallel computation. Some of them, like us, are just simply running it on one CPU. You can see that they have different node lists here, so the priorities can be different and stuff like that. And if you are the admin, you have access to more information, so you can screen who is doing what. If a job is taking so much time, if someone is doing something, you know, not recommended, you can email them, or you can just simply kill their jobs or stuff like that. But for us as users, we just can simply check the queue, and I think it's more helpful if you just simply check your own queue. Apparently, you can have multiple jobs running in your queue, right? Okay, so any questions so far? From here, I wanna share with you project number 1. So we don't really need to be working with Delta anymore. We can just simply type exit. And now I'm back to my local computer. Okay. And whenever you want to log into Delta, I'm just simply pressing the arrow, the up arrow. Recall that it has some of your recent commands, stored. So I press it, I enter. Then if this is a correct SSH link, sometimes it takes some time. Then it requires my password. Then I accept the do push. And I'm there. Okay. So you can identify where you are by checking your account, whether you are on Delta or if I exit, I'm on my local computer. Okay, any questions so far before we move to project number 1? We're good. There's so many documentations out there for working with Slurm. As I mentioned, if you go to NCSA Delta, you can find more information about, some more technical details there. Some of them are, what we practice. For example, we saw how we can check our queue instead of your username, you can indicate the job ID, so you can check the status of your job. And there are, some more information about the partitions or queues that we have on Delta and the node type and stuff like that. So if you're interested, you can, take a closer look at its documentation. But I explained to you whatever we needed, the basic things, especially for running project 1. So you should be fine if you just follow what I taught you today. So with that, I'm switching to Canvas again. I'm going to the modules and then project number 1, which is due by February 19, 2 weeks from now. So if you click on it, there is this PDF file. What I want you to do is to run random module in Python on Delta, and then you are going to test its uniformity, and also you are going to do some other analysis. Okay, there we have a HPC job and histogram plotting. So let me walk you through this project, and then if you have any questions, you can let me know. So recall that we learned about pseudo-random number generator algorithms in general. We looked at, one algorithm together, and we change the parameters in order to have a less cyclical and more uniform algorithm for generating random numbers. But as I mentioned earlier in the class, there exists this random package in Python, and many times you don't really want to start from scratch and design your own algorithm. You just simply import random and you start working with it, okay? So here we want to test that algorithm and see whether or not it generates for us uniform numbers. And for that, you are going to perform a uniformity test first. And as I mentioned, we are running everything on Delta. I know this is not a very heavy job. I mean, you are able to run this on your computer as well, but this is a good practice for you to learn how to work with Delta, your terminal, your commands and stuff like that. So for the next projects, which are getting more and more complicated, you have built these skills, at the time. So the first part of the project is about uniformity test. So you are going to generate 20 pseudo-random numbers using the random module in Python in order to test its uniformity. So all the numbers should be in the 0 to 1 interval. You divide them into 10 equal parts. And once the numbers have been generated, you are going to run the chi-square test. I have added the table in here for you. So if you wanted to check the chi-square number and then compare it with the calculated chi-square that you have the table on page 3. So this part is, simple, and you can just simply run it on your computer. For this part, you don't need to really run it on Delta. The second part is when you have this high performance computing task. So here I want you to log into your account in Delta and then create a new directory. We call it project 1. And then you are going to generate 10 million pseudo-random numbers using the random module in Python, right? And then you want to store the output of that code into a file called random.out, right? So you're basically using Delta only for generating 10 million random numbers. And then from there, you want to look at the distribution of those numbers, right? So what you're going to do is to plot the histogram of those numbers. So it's going to show you the frequency distribution of the 10 intervals that you want to have between 0 to 1. Okay, so you are going to divide that interval into 10 pieces, equal pieces, and then you're going to plot the histogram. It's a little bit tricky to visualize stuff when you are on a remote server. There is a way to do that. It can get a little, tricky. And therefore, what I want you to do is to transfer the output file of your random number generator algorithm from Delta to your computer in order to plot the histogram. Okay, so I have all the information here for you about how you can transfer a file from your local computer to a remote computer. You are going to use SCP. You can see it here, right? So you use SCP in order to copy, to securely copy a file from your computer, your desktop computer, to your remote account and vice versa. So depending on, where you put this information, if you change the orders, you can, change how, how you're transferring the file. But here what's happening is that you're copying basically the random.out file from your account on Access to your desktop. And once you have it, you should be able to use matplotlib for plotting the histogram. Okay, so this is the only thing that I didn't explain today in the class, SCP. Again, you have the command and everything in here. It's a very easy one-line command for copying files between different computers. So you're going to run that on your end in order to transfer files between your desktop and your remote server. And then I have all the information for you in here. If you have any questions about the visualization part, Matplotlib, you can reach out to me or your TA. There are some questions in here for you. So the project deliverable will be just a PDF file. So I don't require your codes, your commands, or anything like that. For this project, you are going to only submit a PDF file. You're going to show us the results of your uniformity test and what exactly it means when you compare the numbers. And then you are going to explain how long did it take for you to finish the job of generating 10 million random numbers on Delta. So this is a question for you, how you are going to measure that time. You may say, I mean, I have my stopwatch, I'm going to use that, but you're a computer scientist, you can do better than that, right? So I'll let you find different ways for measuring the elapsed time when you're running a command. You can either use some functions in Python or you can use some built-in commands in Linux. There are different ways of doing that. And then finally, you're going to show the histogram of the 10 million random numbers that have been generated earlier in those 10 sub-intervals. And then we want to see how they are distributed across those 10 sub-intervals. And then it would be nice to see whether the result of the uniformity test in part 1 agrees with the histogram, the visualization part that you have in here. Okay? So I'm gonna pause here. We still have 10 more minutes. If you have any questions about project 1, I'm going to stay here for a few more minutes. If you have any questions about your job on Delta, if there is something that is not working, again, I'm still here to answer to your questions. If you don't have any questions, you can just simply leave the meeting. And I'm going to stop recording. Let me